We're going to look at an exam question here, and with this Trig applications, or 3D Trig they call it sometimes. They've got this question says that the corner of a rectangular block of wood is cut off as shown in this diagram here. Well, it looks like a slice of cheese, and BDC is sitting on the ground here in that plane. There are two right-angled triangles right there. Three right-angled triangles. That's what those little boxes are telling you. AB goes straight up here, and this side AC and AD are kind of slanting down, and there's a triangle CAD on the top of this piece of cheese right here. These are the sides ABC and ABD. If you can just see it, and you can do all the work with it just by looking at it. Hopefully you can see it. We're going to first do the first question, which is determine an equation for CAD, that's CAD in terms of theta. Well, you look at this CAD, there's a theta down here that's given, that's CDA, that angle, and another theta here that's equal to CAD. Well, together they make 2 theta, but you know this triangle's got to add up to 180 degrees. So the only way for this triangle to work is if CAD was equal to 180 minus 2 theta. Why does that work? Well, if it's 180 minus 2 theta, then when we add it to this 2 theta, we get 180. And angles summing in a triangle tell us that it's got to add up to 180. So you just add those two and subtract from 180, and you'll get your answer every time for the third angle. So there, we answered that. For 1 mark, we got that first question. The next question is, prove that cosine theta is equal to x over x plus 3. Well, there's 2 ways you can do it, but I'm going to show you a way right now. First, we've got to figure out what x plus 3 is. Well, we know that x plus 3 is this, but these 2 angles are the same. That makes AD equal to x plus 3. That's sort of important. And the reason is equal sides opposite equal angles. So there's the first thing we write. AD is equal to x plus 3 because equal sides are opposite equal angles. Now, we can do something else. Now that we've got this whole triangle here, I think, you can use 2 things. You could use the law of cosines, but let's try the law of sines, where we go x plus 3, well, its opposite angle is just theta. So x plus 3 goes with the sine of theta. We can make that ratio. This is law of sines. And then 2x, and the bottom it's given as CD. Well, that goes with the angle CAD, which is 180 minus 2 theta. Well, there's the law of sines. We're off and going now. Now, the sine of 180 minus an angle is really equal to the sine of the angle. So it's just, this whole thing is really sine 2 theta. And then we multiply both sides by it. It'll cancel here, and it comes over to the top here. Well, now we're off and going here. We're off to the races. Now, the sine of 2 theta is really, we use that formula, is 2 sine theta cos theta. Well, that's looking good because now I see that these sine thetas cancel. I've got a 2 on both sides, so I could divide both sides by 2. The 2's are gone. The sine thetas are canceled. I get x equals x plus 3 times the cosine of theta. But hey, I'm just trying to get here. So if I divide both sides by x plus 3, I get my answer. Well, it's possible to use the law of cosines to get exactly the same thing. And all you do is go x plus 3 squared and x plus 3 squared. I'm going to do this kind of quickly. I'm going to show you how you do it. Whoops. Actually, let's see if we can go back. We can get back here, back a little bit. Ooh, let's see. Let's see if it's, there it is. Okay, so if we square this side, the 2x squared, the law of cosines tells us that these 2 sides squared minus 2 times these sides multiplied together, times the cosine of the angle in between them, well, that will equal, that's the law of cosines. That's what 2x squared equals. Well, then, hey, there's x plus 3 squared, x plus 3, that's two of them. The cosine of 180 minus 2 theta is actually minus cos 2 theta, so that makes it plus cos 2 theta. But hey, cos 2 theta is really 2 cos squared minus 1. The 1's leave, you just get cos squared. Now I'm looking at this thing here. What can I do here? I can see that if I divide by 4 cos squared theta, then there'd actually be a 4 here. I'm missing it a little bit here. If I divide by this 4x plus 3 squared theta, that's what cos squared equals. There actually should be a 4 there. Now the 4's cancel. And now if I take the square root of both sides, hey, I get to my answer. So you can use the law of cosine. I did the cos rule to figure that out. Now the last question says, if x equals 2, figure out the height, AB. Well, all you do is you take a 2, you put it in there, you get that the cosine of the angle, theta, is 2 over 5. Well, if you press shift cosine of 2 over 5, you get what theta is, 66.42 degrees. Well, if you cut it in half, you'll get this right angle triangle here, which is 1/2 theta. So that's 31 degrees, 31 half of 66.42. The angle right in there in this triangle ABC must be just 33.21 degrees. And then the sine must be AB, which is the height, over the hypotenuse, which is 5. X plus 3, 2 plus, that's 5. So all we do, 5 times the sine of 33.21 degrees, that's your answer, 2,74 units. Well, that was a little bit long, but there's your 3 questions answered. Okay. Hopefully this will help. And I'm going to stop recording.